So, hello, my name is Arseniy Zhizhelev, and I'm going to present an approach to deal with data and actually with structure of the data. And this approach has been used in a couple of projects, and I find it rather interesting. So you might also find it interesting. So after the short introduction, I will lay out some data representation needs that various application layers have. Then we have some kind of a simple domain model, like a couple of case classes, and we transform it into ontology that represents the same model. Then we will speak a bit about various data representations that is possible with this ontology model, and touch some technical details, how is it organized, and compare with case classes and some architectural influence. So let's begin. Various application layers require different data representations. Actually, at some point we might not have identifiers, or we may fill in some form in a few steps. So, and we may parse data from some external source, and we may have some errors. And we want to represent all this different data, different completeness data, in a unified fashion. Another good example is event sourcing, or CQRS. So you just have some versatile model, but the events touches only parts of it. So you may want to listen to only changes of some property or some collection, addition or removal or something like that. Also, we may want to attach some meta information to our properties. We can use, of course, something like reflection and annotations, but that's not enough. So we may see that different layers requires different data representations, and we may end up copying data from one representation to another. So this is our simple domain model, which is two classes with a few properties and some embedded record in it. It's in Scala, as you see. And now we want to do similar model, but using ontology approach. The first step we do is we just represent the inheritance relationship, because we have it in our model, and we may want to preserve it in other ways. We want the properties to be inherited. These classes do not contain any data, so these are just completely phantom classes. This gives us an option to use whatever data types available in the language, like traits, abstract types, or like calculated types, or something else. So for representing complex domains, this is very useful. So we are not tied to case classes. And the next step, we define properties as objects. So every property that we had in case class becomes a separate object. Here we have some kind of a trick. Property is the constructor of that object, but the name of the property is inferred from the name of the, so let's see, the name of the object. The trick here is that the property object has two types. The left type, which says which record this property belongs to, and the right side, which gives, okay, this is something like that you are going to store in that property. It's not necessarily the data type itself, but it somehow describes the data that is inside this property. And this small trick, there is a library that, using macros, allows to take the name of the variable. It's like a small trick. We can also, well, in the first slide, we had this ontology built just for the particular type. So we take this type and implement all the properties for that. However, we may use cake pattern and define properties for various combination of types. So we will end up in something like a lot of traits that defines the properties for a particular parts of the types. And then when we have some object, that object might implement a few types, this type might be constructed, and we are able to attach whatever properties are available for those types. And we can also use like inheritance to compose this schema for a particular type. Here is an example of the actual data, how it works in this ontology approach. The above case is just case classes, and we see that we cannot easily represent absent data. It's just we need to provide some value. Of course, we can use option or something like that, but probably it's not very good from type-safe perspective. And the second one is that we create records. These are typed maps that use properties as keys. So we can use property not just as an object itself, but we can use it as a key in a map. We can associate some meta information with it, or we can do whatever else we want, because it's a standalone object, and we can do whatever we want. But the fact is that the amount of boilerplates is exactly very similar. So from the user's perspective, this is very, very similar approach. So let's see what different data representations are possible. The first one is typed maps. These use property identifier as a key within map. And we avoid this casting the data to a particular type because we already know the property type and we never get any mistyped things. So this is one of the way. The other way we can use JSON, because JSON is a very versatile data structure which is available to any languages probably, and it's very good because it can represent sparse data. The only problem is that it is not type safe. So if we use ontology and wrap this JSON object into some wrapper, typed wrapper, then we have completely type safe JSON work. And it's kind of a good thing. We can also use case classes directly as a data storage. We just need to map our properties to some kind of a lens or functions that we want to use. So if we want just to read data, we just can use functions that gets the property. Or if we want to update something, then we use lenses. The other important thing is that we can map our data into HList in a type-safe way, because on the property side we have the type of the data which is in that property, and from that we can construct HList that contains all the things typed, and this gives us the way to interop with like Slick or other database access layers. And of course, custom representation are also possible. So this is not actually a library, it's an approach, because there is not much to be done as a general tools to work, because you can implement property ID, just a single line of code, and nothing more like that. Probably some kind of tricks like taking the name of the property might help. However, it's very, very small thing. So there is, of course, GitHub repository with this stuff, but in my projects, I often find it more convenient to re-implement it because there are some nuances. So you can put some meta information directly into property ID, and it is convenient. So at the first layer, this is data representation layer. We can use typed maps, typed JSON, or something like that. Then we have another abstraction layer where we define ontology. So we define our properties, we define the structure of inheritance, and this is like the main model. This can be specified in one place for the whole application. So you will be using the same ontology in every layers of your application, and this means that you have single domain language for the complete application. There are meta tools. meta is a part that is inside your application, but it's more like a system level thing. It cannot be generalized for all, but this meta has, because people want to attach some additional meta information that is needed for the application. That's why this meta layer contains these tools to associate this metadata with property. And this meta of meta, it's the next abstraction layer, that contains some tools that are reusable across various data representations and all the property IDs that you want to create. These are kind of type classes, reusable. So what are the limitations of case classes compared to ontology? Well, of course, we can do a lot of things with case classes, but ontology gives a different perspective. That's why I'm looking into the difference. So when we use case classes to represent data, we use different sets of case classes at different layers, and we have to copy data from one set of case classes to other set of case classes. And this is error-prone thing. We have to introduce some optional fields or fields of type try to represent either incomplete data or unparsed data or something like that. For the event sourcing, if we have some kind of event sourcing application, then we have to create like a set of data classes and then set of events, and then we create an interpreter for those specific events that work on those specific case classes. And this is not reusable. Using ontology, we just define universal, well, I had this kind of, we create a universal case class that represents like property has new value. So we create this case class, and it is reusable for all kind of events that about property changes. Then we can represent some meta information about properties within case classes, but it is not first-class citizen. So you have to use some kind of annotation, reflection, and something like that. And you cannot attach type class to a property. So it's not that good. And the ontology approach has these benefits, like we can use different data representations, and we use single domain language through all the application. This is, here it is. Here is the case class that allows us to represent event. This case class, we just say, okay, that instance has this property, and this is a new value for this property. That's it. And this can be interpreted in a single place. You create an interpreter for all those instances, and there is no need to recreate and repeat yourself. And meta information is actually very easily can be added. For instance, we may attach some UI tags, UI hints to properties. For instance, if we have property of type string, we can say, okay, it's just a small string. Or we may attach some constraints like problem domain rules that we want to check on this property, and we can interpret those constraints either on UI or on the parsing side or somewhere else. So this is convenient. And of course, ontology gives you the advantage of having, from one side, it's a single domain language, and the data representation can be various, and you may use whatever you want to represent the data. If we consider this approach from the architectural perspective, it gives us the great change in our application, because it's a domain-driven application. If you want to add new feature, you create new domain model, but most of your application will remain the same because there is no need to repeat your code. You just create new entity, define properties, and that's almost it. This approach makes it easy to do metaprogramming because we have properties like first-class objects, and they are available to traverse and do whatever we want. So we can automatically create parsers. We can create database structures. We can generate case classes from it. So it's very convenient from this perspective. And again, event sourcing is easily done. And data transformation. As soon as we have different data representations, we can transform the data in completely automated way because we have a schema of the data and we just transform this data. So it's very easy to do this. Here we are. So this approach worth trying it. So you may, well, if you don't use Scala, don't worry because it is very easily implementable in any language. You just need to keep 2 types. Well, if you don't have types, then you don't worry about types. But if you have some kind of Haskell, then you need 2 types, the left side and the right side. So it's easily implementable. And we have some benefits like various data representation, unified domain model, and that's a really useful thing. So I wish to say thank you to Lambda conference organizers because they gave me an opportunity to attend this conference. I came from Russia, so it's very difficult. And I want to say thank you to the company that I'm working for, Activity Labs, that supported me. And there is a person who gave me sponsorship, but he is very shy and he decided to not being mentioned here. So his portrait is here. So now I'm ready to answer your questions, if there are some. That's it.
I don't know if it came up with the type of record. Was that on the slides at all?
Type of record?
So I saw instances of it, but I never saw the type. Or maybe I missed it.
Probably it's not, but it's just phantom type.
Sorry, property. Property is the one I'm thinking.
Property?
One that has the 2 type variables.
This one, this like property here, right?
Yeah, so that's a value of the type.
Well.
Do you know what its definition? Like, did you show its definition? I don't think.
No, I didn't give it, but it's just a case class with the name. It's very simple as that. But in real applications, we usually put there something additional, like we use runtime type information put there, and some description, and something like that. So probably it's more convenient, for instance, to put JSON property name into the property itself. So we have something, it's easily mappable. And we can transform those phantom types, map those phantom types to actual types in Haskell, just using a kind of functor. Okay, so it seems that that's it. Thank you for your attention.